Good morning, everyone. Let me know if I'm audible and you can see the screens. Hello, am I audible? Hello?
So,
Can anyone respond? Can you guys hear me?
yes, sir.
Yes,
Okay,
sir.
thank you. Let's start. Today we look at the last topic of our module 4, which is broadcast and multicast routing. So far, our calls, whether it's the OSPF, BGP, RIP, or the two category link state, distance vector. The purpose of all these routing protocols were to make a routing table entry. And when a router gets a packet, the packet is forwarded as per routing table to the next hop and gets delivered. All these routing tables are meant for unicast routing. We discussed that 4 kind of addresses. One is called unicast, broadcast. I would like to explain what the difference between unicast, multicast, broadcast, and anycast. Anyone? I want to make sure that you understand the basic concept. Bhavasri, Sairam, Pavan P, Soumya. Anyone like to say the difference? How to identify unicast, multicast, broadcast, and anycast? No one? Rakshit? Muhyiddin? Are you guys there? Or simply attending the class, sign in and go away? That means all the guys named are not there in the class. Sahita,
Sir,
yeah. What is the difference between anycast, multicast, unicast, and broadcast? If you don't know, tell them you don't know. If you know, try to give the answer.
I don't know, sir.
Shalini S. Sasank Ji.
Sir, unicast means giving casting or sending the message to only one person. Or broadcast is to all who are all in the network.
Okay, good. And what is multicast?
Multicast more than one, sir.
What do you mean more than one? Is there more than one could be all as well?
No, like the
Sir, to a
network
group,
subnet
sir,
what I have,
to a group.
a subnet
Hello?
what they have to the local network, sir.
No, need not be local network. Okay. So basically, yes, multicast is more than one.
Sir, to a group of people, sir.
Group of people or subset of machines in the system, that is multicast. And what about any cast?
Sir, to some random machine.
No, any cast is not a random machine. I discussed when I talk about IPv6, what does any cast mean? So in all the cases, there is only one sender sending a packet. Unicast means packet is to be delivered to one specific receiver identified by the destination address. Broadcast means sender sends only one packet, but packet is to be delivered to all the systems in the network. Multicast means there is only one sender, but packet is delivered to group of machines which is well defined, identified, and packet is delivered to only those machines. Anycast is somewhere between, you can say, mix of unicast and multicast. So anycast normally means a number of machines has the same IP address, same address. But packet is delivered to the nearest one, the one of them. And typically it is the nearest one. For example, let's say each college has a canteen, so address is canteen. And say, let me go to canteen, it implies that I am going to my college canteen. So every college has a canteen, same name, canteen. But depending on where you are, you go to the nearest canteen. So this example would be of any cast. So number of machines, same address, but package is delivered typically closest to you, and that would be any cast. So far we looked at the routing tables. They were only dealing with delivering unicast packet, that is sending a packet to a specific machine. Now, if I were to send a broadcast packet or multicast packet, I send only one, or at least objective is package to be whether I send one or I can send many. Objective is this packet is to be delivered to all the systems which are present in the network. What could be the simplest approach? Simplest approach would be if there are n receivers, as a sender, I make n copies and send one copy to each of the receiver. So sender ends up duplicating number of packets for the each receiver. The key benefit is because each packet goes as a unicast, my network infrastructure is already designed to handle unicast packet. We don't need any new routing protocol to deliver broadcast packet. When I say I'm implementing broadcast as a n-way unicast, meaning I'm making n copies of the packet, one for each recipient with their individual unicast addresses, then I'm actually sending n number of unicast packet, and my network knows how to deliver unicast packet, so I don't need to have any network layer routing protocol. And there are no changes in the network which is required. Simplistic approach works fine, but it has its own challenges. It is highly inefficient, as we'll see shortly, and there are a few other issues with it, maybe traffic congestion or something of that kind. Let's look at the simple diagram which consists of four routers, R1, R2, R3 and R4. R1 is connected to R2, R2 is connected to R3 and R4, and R3 is connected to R4. Now R1 needs to send a broadcast packet. That means R1 needs to send a packet to R2, R3 and R4. If we're taking a simplistic approach, R1 makes 3 copies of the packet, one with each destination address of R2, R3 and R4, and the packet is sent. If there are assumed total 10 if there are total of 10 routers in the network, R1 would send 10 such packets. And this is what broadcast would be. And this is also called, we are duplicating at the source. And this duplication at the source is considered inefficient. Why would you like to say that this duplication at this source is inefficient, and how we can make it somewhat better? Any suggestions, thoughts? Why this is inefficient and what we can do to make it more efficient? Anyone? Sindhu AS? Souvik Mandal? Sri Chandana? Why this is inefficient? Shaktivel? Sri Chandana, are you there?
Yeah.
Then tell me, if you do duplication at the source level, assuming there are 100 routers in the network, that means I need to make 100 packets, send it to each. What is the issue with that? What would happen? No clue? Shaktivel? Let's start thinking what could be leading to this problematic case. Is there n number of destinations, duplication at the source, I need to create n packets. So what happens to this link R1 and R2? How many packets will be transmitted on this link R1 and R2? All the n packets. Do we need to transmit all the n packets, same packet, going on the same link, and this link would be choked? So, and that's the reason of inefficiency, because this link will choke the particular, get choked because of the number of packets, and that will be one problem. Other problem is, how does sender know what are the machines? Do we need to build another protocol to determine how many machines are there in the network? That means every time somebody joins, somebody leaves, they should communicate to everybody, I'm there, not there. And that routing protocol itself will be too complex. Now this avoiding duplication, choking the link, what is the next best approach we can do? Rather than duplicating at R1, can you duplicate at R2? Will that somewhat solve the problem? Or will that remove some inefficiency? So R1 sends only one packet. R2 decides how many routers connected to and create that many copies and sends on those links. Will this approach be better than the source duplication? Hemant Chaudhary?
Sir, do know.
What is that? Can't you see what could happen? The two approaches, what you're saying is, either R1 duplicates, let's say there are 100 routers, R1 sends 100 packets, and you have a whole kind of tree connectivity, or rather than R1 sending 100 packets, R1 sends only one packet, R2 makes as many copies, as many links are there, so each router makes that many copies as the links are there. So will you prefer
Sir,
the second approach or will you prefer the first approach?
first approach reduces time, sir.
Why will you prefer the first approach?
Sir, preventing choking, sir.
The first approach is causing more choking because the R1, R2 link, I'm sending 100 packets, link would be choked. In this second approach, there is no choking. Because
Yes, sir.
sending only one packet.
Second, sir. Second one is more choking, sir, than first.
Second one is more choking.
Yes, sir.
Why?
Sir, time.
In what way? In first case, R1 is sending n packets. In second case, R1 is sending only one packet.
Yes, sir.
So which one would be more better?
Sir, first one has the more choking, sir. Second one is better.
This is what you are saying. So they were used to be able to say that.
Okay, sir.
Now, do we see with this, is there a problem with the second approach?
Yes, sir.
What is the problem with second approach?
Sir, it's time.
Time in what sense? Same time is taken here itself. In fact, when R1 sends 100 packet, it will take a lot more time.
But second is better, sir.
So second is better. This time it doesn't choke the link. But what could be the problem? There are few other problems which we look at. So first is, we said we need to have some protocol to discover how many machines are there in the network. That itself is more challenging. Further, what we have done, when you send OSPF packet, when you send link state packet or distance vector routing packets, those packets were sent as broadcast to so that anybody on the router would receive. So we were building unicast delivery using broadcast. Now we are saying we'll implement broadcast delivery using unicast, just the reverse. That completely reverse process, the two cannot go together. It's kind of chicken and egg problem. So it pretty much unwise. We do use broadcast to implement unicast routing. We'll send only one packet. Now where we're doing the reverse, which doesn't make sense. So we'll look at what is that we can do when we do in-network duplication. Let's look at the case when R1 needs to send, simple case, R1 needs to send a packet to R2, R3 and R4. R1 sends only one packet. Then R2 will make a copy, give to R3, gives to R4. So each router, when it receives a packet, makes as many copies as on the link, other links, outgoing links, and sends a packet. So R2 makes two copies, sends to R3 and R4. R3 receives one copy, sends on R4. R4 receives one copy from R2, sends on R3. So what would happen? R2 made 2 copies, sends to R3, R3 will give to R4, R4 give to R2, and this package will keep on cycling. Same way when R2 makes a copy, this package will keep on cycling like this. So first problem when we do with in-network duplication, this problem was not there with this sole duplication because each packet was going with the individual unique IP address of each router. So problem was choking, but it was no issue of cycle. Here in network duplication, when R2 creates 2 packets, one to R3 and one to R4, now this packet will keep on circulating like this, other packet keep on circulating like this, and that causes cycle. Assuming I had one more router here, R3 and R4. So what could be the problem there? So let me say if I can show something, maybe let's see if I can show that. So let's say I have R1 here, this is my R2, this is my R3, this is my R4, and then I have R5, so I can give a name. This is R1, this is my sorry, I'm not able to write that. So let's say this is R2, I can write it maybe with the free pen itself. So I'm connected like this. So this is my R1, let's say this is router 1, this is router 2, this is router 3, this is router 4, and this is router 5. And this router R1 has to send a packet to 2, 3, 4, and 5. So R1 sends one packet to 2, 2 makes a 2 copies, gives to 3 and 4, 3 makes 2 copies, gives to 4 and 5, 4 makes 2 copies, gives to 3 and 5. Will there be a problem with this approach? Vasak,
Yes, sir. Yes,
what's the
sir.
problem?
Sir, unnecessary copies are being made.
Created. So even previously we were getting unnecessary copies. If this link was not there, packet only circulating, but network could handle. Will it be only circulating again or could there be deeper problem?
Time issue, sir.
What time issue? Packet have been delivered, they get multiple copies. Could there be bigger problem? Look what happens here. When 2 gets a copy, it makes 2 copy, gives to 3 and gives to 4. 3 makes 2 copies again. Packet will come, it gives to 4, 4 makes 2 copies again. It goes to 2, 2 makes 2 copies again. So for each packet,
Sir? Sir, you are not audible. Sir?
Hello guys, can you hear me now?
Yes,
Yes,
sir.
sir. Yes, sir, we can hear.
I think college network went down, so I'm working through my hotspot. Hopefully this should work. So you were saying something like what I'm saying is, if you look at here, can you see my screen? No, it doesn't look like. So if there is a router R4 or R5, it will be broadcast the store because each R3 and R4, each time they get a packet, they would make two packets, and number of packets would keep increasing in the network, and at some point network gets so many packets, it would get choked completely and nothing would move. So if you were to do in-network duplication, you might have a problem of broadcast system. And of course, the other issue is the network were disconnected, nothing would work out, to a bigger problem. So how do we avoid this control flooding? If we do basic flooding, basic flooding means if I receive a packet, I recreate the packet and send on all the other links other than what I received. But that could lead to cycles and that could lead to the broadcast stop. So we need to be choosy about when to flood and when not to flood. So first approach is called control flooding. This is what we have seen in link state routing. So that basically means I will send a forward a packet only if I haven't forwarded it again. Previously. So when A sends a packet, so let's say B and C, A want to send a broadcast packet to all of them, B, C, D, E, F, G. A gets a packet A sent to both B and C. C will send to B, C will send to E, and C will send to F. Similarly, B gets from A and B will send to C. Now C already sent the packet to F and E. So when B forward the packet to C, C would not forward it. That means a router would forward a packet to other links only once and not every time it receives. How does it do that? Basically makes a copy, it remembers what kind of packet is forwarded. So each packet by sent by a source, it puts a source ID and some unique packet ID. And when a router forwards, it keeps a copy in the cache and forwards it. And next time it receives, it won't forward that packet again. And in that sense, there will be no flooding. Only thing that will happen is there may be what is called a machine may receive multiple duplicate packets. And what we call is sequence number control flooding. That means A will put a sequence number with own ID, C will send to F and E and B. B will also receive from A and B will forward to D and G. But when C sends to B, B has already forwarded it, so B won't forward it again. Same is true for C, and this is control flooding. Because I remember what I forwarded, I won't forward it and that solves the problem. But the challenge is for each router in the network, I need to remember, store what packets I have forwarded. It works fine, but I need to have more memory, consuming, and keep doing every time I get a packet, I need to look at what could be happening. Memory, see if I forwarded this packet, if not, then I forward it. Other approach is what is called reverse path forwarding. In reverse path forwarding, when I receive a packet, let's say E receives a packet, E would receive a packet A to C and C to E. E would also receive a packet A to B, B to D, and D to E. Now when E receives a packet, should it forward it or should it not? So decision making is when E receives a packet, it knows that who is the sender. Let's say sender is A. E determines using its own unicast routing that if it were to send a packet to A, which link it would choose. And assuming we are using shortest path algorithms, when A sends a packet, it would receive from C, it would receive from F, it would also receive from D, same packet. But when E receives the packet, it looks at the packet came on which path. Is it on the shortest path to A? So the packet that came from C, because E to A path is E to C and C to A. So the packet that came from C is on the shortest path, and only that packet would be forwarded. When E receives a packet from A to C, C to F, and F to E, it decides F is not on my shortest path to A. That means I would certainly receive a packet on my shortest path from C. So when E receives a packet from F, it would not forward it. So that way it doesn't have to remember in memory what packet it has forwarded. But it still need to do computation to look at the is it a shortest path or no. So same way when E receives a packet from D which sent by A, E would not forward the packet again because D is not on shortest path from E. Shortest path for A from E is ECA. So packet comes via F, it does not get forwarded. If packets come from A, B, D, E, again this is not forwarded because D is not on shortest path. So this mechanism is called reverse path forwarding. Are you still seeing a voice loss or is the voice still okay? Can somebody answer? Can you still hear me properly?
Sir, sometime voice is getting lost.
Yes, I see some packet loss. So if you see, ask me to repeat. Because college network is down, so I'm using my own this thing. So if it gets lost, let me know. I'll repeat. So let me repeat. When a router receives a packet in reverse path forwarding, it will forward to other links only if packet came on the shortest path. Let's look at the packet received by C. When packages come from A to C is the link which is shortest path to A from C. So when C receives a packet from A, C would forward to both F, E and B. Now this packet which is forwarded by C to B, when B receives it, B sees that packet is from A, but it came via C to B. Now B looks at the routing table to determine which is the link I would use if I were to send a packet to A. And B to a path for B, packet has to go on the link B to A. And when packets come via FC, that this is not on shortest path, it would not forward. It can so happen that A to B link is slow, A to C and C to B link is very fast. So the packet sent by A may come much later than packets came by C to B. But it knows that because the link is available, I would eventually receive a packet and it will B will forward a packet only when it comes from A and not from C. And this is what is called reverse path forwarding. That means you forward a packet if it arrived on a shortest path. Otherwise, you discard the packet. And that solves the problem of again not flooding the network. There's no cycle, there's no choking. But still there is a one challenge that a node can receive multiple copies of the packet. Let's look at in this example how when A is sending a packet to all the routers and when we are using reverse path forwarding, how many copies E would receive? A want to send a packet to all the routers, a broadcast packet, and we are following reverse path forwarding. How many copies E would receive? Anyone? Pujashree, Jana, Yogita, Vishnupriya, how many copies he would receive? And that's the kind of question I'm going to ask in the exam. It is difficult to compute.
Sir, 2 copies.
Can you tell me why 2 copies?
Sir, since it gets from the shortest path from A to C, it will receive to E,
Yes.
and then from A to B and B to C, it will receive, sir. These two are the shortest path.
No, see, so A to C, C to E, A to B, B to D, and D will forward it. Because when D receives a packet, it receives a packet on the shortest path. It will forward it. When F receives a packet from A to C, C to F, this also came in shortest path. So F would also forward it. Is that okay?
Sir, repeat, sir. We didn't hear you.
Hmm?
Sir, could you repeat, sir? We didn't hear you.
Let's look at when A sends a packet and we are saying a node forwards only if arrives shortest path. A sends a packet to C and B. C receives it on the shortest path to A. B receives it on shortest path to A. So C will forward on all the links. That means C will forward the packet to F. C will forward to E. C will forward to B. Similarly, when B receives it from A, B will forward to C and B will forward to D. Now, when B forward this to C, when C receives this packet from B, this packet is not on shortest path to A, because shortest path to A is C to A. So when B forward the packet to C, C would discard it. But when C receives the packet from A, this shortest path, so A will forward to F, A will forward to E, and A forwards to B. Now, when C forwards to E, he received 1 copy. When C forwards to F, F has received this packet on the shortest path to A, because shortest path to A is A to C and C to F. So when F receives it, F is receiving the packet on the shortest path to A, so F also forwards to E. So E receives second copy. When B receives it, B forwards to D, and D receives this packet on the shortest path to A, which is D to B and B to A. Because D receiving the shortest path, D also forwards to E. So that means E would receive 3 copies of the packet. One from C, one from F, and one from D. E will forward only those copies which it receives from C, but not others. But E is still receiving multiple copies. Is that clear?
Sir, you said C discards when it gets to B, no, sir? It gets from B.
C will discard if it receives packet from B.
Yes, sir.
But
Why
C would
when
forward, but it will receive from A. See, when C gets a packet from B, is this on the shortest path to A? C2 is shortest
Okay.
path is directly. C2 is shortest path is
Okay.
not
Okay.
via B.
Okay, sir.
Okay. So this is the reverse path forwarding. I will forward only if packet is coming on shortest path, not otherwise. But so that means at least I don't cause flooding, but I still receive multiple copies. Can I even avoid that? And that approach is called, can I use spanning tree? What is a spanning tree? Vijayashree, given a graph G of n nodes and E edges, how do you define a spanning tree? Yogita,
Sir, it covers all the vertices in a graph with minimum number of edges.
how do you define minimum number of edges? Minimum number of edges could be 0.
It should it should visit all the vertices.
Yeah, so I have a complete graph. I take all the vertices with no edges. It has all the nodes. The minimum edges is 0. So what else is needed? So that is not a fully correct definition. Jana, Jaswant, Vegeta, what is a spanning tree? If my graph has n nodes, for a spanning tree, how many edges would be there in the spanning tree? Vishnu Priya,
So n minus 1.
yes, so can you define what a spanning tree is? Yes, a spanning tree would have n minus 1 edges, that's right. But how do you define a spanning tree? So spanning tree is a subgraph of graph G, which has all the vertices which are there in G, and it has edges such that there is no cycle in the graph, and each node is reachable from everybody else. So graph is connected. That means there is a path exists between any two nodes, but there is no cycle. If a graph has n nodes and if you have n edges or more than n edges, they're going to be cycle. And there is n minus 1 edges. I can still have n minus 1 edges with cycle and some graph may not be reachable. Let's say in this graph, I can remove the edge dg and keep the edge de. So if I remove the edge dg and keep the edge de, still there are n minus 1 edges, but graph is disconnected. So the spanning tree is a subgraph of G which contains all the nodes which are there in G and edges such as that there is no cycle in the graph and between any two nodes there exists a path. That means graph is connected. So it is a connected subgraph such that there is no cycle and it has all the nodes of the original graph. So if somehow we were to build a spanning tree of the graph and then a node sends a packet only on the edges of the spanning tree, a node sends a packet only on those edges which constitute a spanning tree and does not send packets on any other edges. So when A sends a packet, A sends to only B and C spanning tree. So C sends a packet to F and E. C does not forward a packet to B because edge B, C is not part of a spanning tree. When B receives a packet, B sends to D. D sends only to G and not to E because D is not part of a spanning tree. So if I am forwarding packets only on those edges which are part of a spanning tree, then no node will receive duplicate packets. That's the benefit of spanning tree. Even if, let's say, D were to send a packet to all, so D would send to B and G, not to E, because this is not the spanning tree edge. B would give to A would go to C would go to F and E. So when a node receives a packet, it sends only on those edges that are part of spanning tree and not others. This way we are ensuring that a node receives only one copy of a packet. A node would never receive two copies of a packet. But the major problem with the spanning tree approach is how to build a spanning tree. Building a spanning tree itself is a challenge. And that means we need to have some mechanism of building a spanning tree. So one approach is called center node or rendezvous node approach. That basically means somehow the node decides which is the root of the spanning tree that becomes a center node. And all other routers, so it's a different problem how to do the center node. That still remains a problem. But assuming we have decided that particular node is a center node, for example, source node with minimum IP address, some criteria we choose and decide a node which is the center node. And all other sends a joining message to that node. So consider that my E is chosen as a center node. When E chosen as a center node to make a spanning tree, all other nodes will send a message. So first C sends a message to E or F sends a message to E. F sends a message to E and this edge becomes part of the spanning tree. B sends a message to E and B follows the path D and E. So both the edges BD and D becomes part of spanning tree. Next, A sends a message to E and assuming A follows the path B, D and E. When A sends a message to E, it comes to B. B has already become part of spanning tree. So B does not have to forward this message. So A node forward the message only if it is not part of a spanning tree, and if a node receives a joining message which is part of a spanning tree, it just the edge becomes part of spanning tree, does not forward. Same way C sends a message to E and same way when G sends a message to D. So my spanning tree is like this: C to E, F to E, D to E, B to D, and that way. So you basically send a message to the node, and if node is already part of spanning tree, the message is not percolated, otherwise it is percolated. So this is the way spanning tree is made, and once a spanning tree is made, each node knows only the edges which are part of spanning tree, not the other edges. And node will send a message only on the edges corresponding to spanning tree. So the only challenge is once you build a spanning tree, which itself is a challenge, but assuming the spanning tree is built, then node forwards message only along the spanning tree edges to the neighbors. Node needs to know only the neighbors. D needs to know only as E, G, and B, nothing else. A only knows to know B, and B send message only in the spanning tree edges. So there is no packet, there is no duplication. A node receives only one copy of the packet. There is no flooding, no pervasive. The only challenge is how do you build a spanning tree. This way, we look at how to build, we look at the approach, and same thing we look at when we deal with multicasting. So in broadcasting, we typically do like my link state routing message, OSPF send broadcast message. And you basically send a message, keep the message ID, and maintain a basically do what is called control flooding approach. And to make sure the packet doesn't go forever, you keep a time to leave field and get discarded. Even though it looks simple, it does the control flooding. It forwards duplicate packet can be received and discarded. Next class, we'll look at multicasting. So we'll stop here. And so questions would be again on the understanding the protocol and applying. I'm not going to be copy paste from the book. Yes, yes, Bob. Questions, tell me. Any questions?
No, sir.
Okay, thank you guys. Then we can stop. And if still question, ask me. So we are done. Prepare well for the exam and do well.